The monthly cost in dollars of mining a certain ore is related to the number of pieces of equipment, and then we're given this cost function. So I want to take a look at the graph first. So I'll do the number of units and the cost. This one's hard because to know where to start, the number of pieces of equipment, I don't know, might be in the thousands. These are awful big numbers, but then, yeah, I'm not sure. I'll just start with 10, 20, 30, 40 and plug in the cost. Those are big numbers. Let me graph it, see what I've got so far. Okay, so I'm trying to minimize the cost, and so far I don't have a graph that has a minimum, and it doesn't look like it's going to get smaller over on this side. So I'm going to investigate, change my number and look more between 0 and 10. If I put in 0 though, I get a divide by 0 error because 0 is not in the domain of my function. So the smallest I could go would be 1. And now just with those 4 values, I can see that the costs are coming down. So this looks productive. Let me continue on. And then because, let's see, when I click on the graph, notice that my data only went down to those rows, down from row 12 to row 15. But if I grab onto this handle, I can select more of the data. And now I can see from the graph that the minimum is either 4, 5, or 6 right in there. To figure out which one it is, I'll pull up Solver. And you need this icon for the solver. And to get that, if you don't have it, it's in the analysis tools. And just click on, like if that box isn't selected, then click inside the box to select it. Okay, to solve parameters, set the objective. So my objective is to minimize the cost. So my objective function is in the cost column. To change from max to min. By changing in the variable cell is the number of units that created that value for the cost. Subject to constraints, don't worry about these for the moment. Unconstrained variables should be non-negative because we don't want to deal with a negative number of units, and you'll want non-linear solving engine. Then solve. And it found 4.869, and that my minimum cost was 340,000. Keep the solver solution. And then let's bring up WebAssign. How many pieces of equipment to minimize the cost? Only whole numbers of equipment. So the 4.86, let's round it up to 5 and submit.